So this, to describe it once again, this is your starting point for the requirements elicitation. Once you define it, you define your business strategy, business requirements, then go into the feasibility study, which will result you to define the user requirements. Once the user requirements are defined, you can define the system requirements, basically. And the system requirements will cause you to create a model which then you can review and generate it. This whole process where the user and system requirements are defined is called system elicitation. Sometimes this is combined with system analysis as well. Elicitation is the first step of requirements engineering. It identifies the application boundaries and services. So this means that whatever the program is gonna do is gonna be defined at this very stage. So requirements elicitation is followed by the activity of the analysis, where also requirements specification will take place. Requirements discovery, requirements classification and organization, prioritizing and negotiating some of these requirements are some steps that can be included inside the elicitation phase. So once again, this will generate you a circle where you discover, you classify, you prioritize, and you specify these requirements, which will then again go back to the discovery. Just as you can see in the next graph, it generates you a circle. Everything you see in this course is a circle, every single diagram, because the software process is not something you can end up. As soon as you end up it, you basically risk the software to wear off. Elicitation and analysis, despite being different steps, they are often combined into one. Okay, so this is a common practice that is done. So instead of taking them as separate steps, it is actually combined, because it helps to communicate with the stakeholders to discover the requirements, both business and domain requirements. And it also helps to prioritize the requirements specification. The requirements specification is followed by requirements validation, which is probably one of the most important steps in requirements, because validation is regarded as something that should demonstrate the requirements, that these are actually what the system needs. Usually, before you do any kind of validation, you will do a modeling, so that it can help you to review the requirements. It could be a small demo of the program that you are developing. It could be basically an abstract thing to show to the stakeholders, so about your vision. So some kind of development, a small prototype can be done in here before you go into the requirements validation section. It could be very difficult if you don't do modeling to convince that these are the actual requirements for you. And do not forget that stakeholders are investing money into your project, because software business is expensive. If you don't do the validation, you risk facing two important problems. One, if you didn't consider a requirement, it might be very difficult to basically deliver it at a later date. Fixing a requirement error after delivering may cost up to 100 times the cost of fixing an implementation error. It is an expensive thing, software business. So if you actually define the requirements well enough, even though their chances to change are very high, at least you reduce some of your cost at a later maintenance phase. So this is probably the most important step, to make sure that those are the requirements that you actually need. So like I said, a good strategy here is using prototyping. Using executable models of the system is a good strategy to make sure that the requirements are validated. We discussed prototyping before. Another strategy arises from Agile. Do you remember test-driven development? That is also a strategy. So you basically generate test scenarios before you actually develop the software, and during the development, you test those scenarios. This is also a way to validate, and I showed you some job offers, if you remember, on LinkedIn, that many people hire test-driven development people in agile development so that their requirements can be validated efficiently. There are, if you're going to work in a plan-driven organization or a company, this means that there should be a requirements documentation before a design phase. However, there, first of all, because our industry does not have universally recognized standards, we do not know or have a specific documentation structure. So how this document is written changes from one project to another, let alone in between the companies. Another important issue is that not every company or every business generates a requirement documentation. Like I said, in many agile development approaches, requirement documentation is seen as a waste of time and money. So instead of doing that, they will basically follow something like a test-driven development structure or rely on customer stories. While there is no universal standard to write the requirements documentation, because basically it is a statement that is explaining what the system should do, there are important things that you might need to pay attention. First of all, this is not a design document. A big trap that developers fall into is that they regard requirements documentation as something like a design documentation. So they focus on how these things will be achieved rather than what it should do. So before you decide on how it should be delivered, you should actually focus on what the system should do, and that is where the requirement documentation come in. Another fall is that this kind of document does not have any room for ambiguity. It means that any kind of vague definitions shouldn't be placed in the requirement documentation. Everything should be at least in range or roughly have an idea on how what should be done, not how, but what should be done. So avoid ambiguity when writing requirements documentation, such as when you say the system must pass between 70 to 100. This is a huge gap. There's a huge range here. So is it at 70? Is it 100? You know, there's a big difference in between. So this is a very vague definition. Another mistake that can be done is being very subjective, such as the debug code must easily and seamlessly. What is easy? To me, Java is very easy. To another person, it could be the most difficult language. So these are very subjective terms, okay? There is no room for them in the requirements documentation. Optionality. The software should be tested under as many operating systems as possible. What does it mean, as many operating systems? Does it mean like Windows and Mac only, or Linux and others? Like, what is it? It's again very, very vague. There's no definition for it. Under specification, the software must support TCP/IP and other network protocols. What is other? Again, no definition. User must be able to complete all previously defined operations in under 5 minutes, 80 of the time. No idea what the hell that means. Under 5 minutes, 80 of the time. So it means like 80 percentage every minute, or is it something else? Like, this is like a very complicated statement. It can change from one person to other. So you need to avoid this kind of wording, and it actually reveals how serious you are with the project when you write the requirements documentation. Luckily, we have some examples which we can see a generic structure of what could be done. I hope this thing works. Yes, it does. So you know IEEE, I guess. How many of you know IEEE? Can I see some yes or no on the chat? Are you awake, guys? Can you hear me? Hello? Why are you not replying? So IEEE is the International Electrics and Electronics Engineering, which basically define the standards in our discipline. They have a requirements documentation structure that you can see in here. So basically it says that there should be an introduction, an overview, a description for your product, functions, characteristic, constraints. Remember the constraints? And specific requirements. This will include, of course, functional and non-functional requirements, as you can see. And finally, your documentation will be done. This is a suggestion, of course. You don't have to follow it to 100%, but it is a suggestion given to you when you write a requirements documentation. So one of the most important and things that you should always remember is that no matter what you do, how well you write, requirements is gonna change. It's like chasing cars, as we call it in English. It's like it's something that you are not gonna achieve 200%, but you can reduce the risk and you can reduce the damage that you might take in the maintainability of the project. Large systems usually have diverse user community with many users having different kind of problems. So spending too much time on finalizing the requirements sometimes costs more than anticipated. You need to basically find a balance of support to a different user range. So even in Agile, if you focus on too much on what the user needs and try to deliver them, then you're not going to have time to even go beyond the design phase if you spend too much time on the requirements. What we should know in here is that the requirements will change and you cannot make everyone happy. You need to make sure that you address the majority of the requirements, the most important ones, so that these will be delivered in the early versions as you promised in the project, and leave some of the requirements for the maintainability part, which then you can deliver them in the later versions. And this is actually how most of our business work. Even in interactive media or mobile phones, not everything is supported in one go when the software is released. And as the product is released, they can add more features to it, such as some of the features on Instagram or Facebook Messenger didn't exist back in the day that they were released. On the way, as the months and years passed, they receive customer feedback, and these programs, these apps, are changed. The same can be told for many mobile games or interactive media. So some of the games that you might see on the mobile platform or the apps, they didn't have some features at the beginning, but then these are added later on. So this comes from the fact that the requirements are an ever-changing process. So what you do in the requirements documentation is that you focus on the most important ones, the ones that are vital and must be critically, delivered, or otherwise the software would be in an unmaintainable phase. The business and technical environment of the system always change. New hardware can be introduced. For example, new phones, new computers, new technology can impact on the requirements, of course. The people who pay for a system and the user of that system are rarely the same people. Another problem of changing requirements is that you can run a study and people can tell you that they need a taxi app in Cyprus, which was tried before actually, and then suddenly, while everyone says yes, we want to have a taxi app, we want to actually use it. When the app was released in Cyprus, nobody used it, so the app died. So this means that not in every case that people who pay for the system are who say that they're going to pay for it are the people who are going to basically use it. So this has to be researched before you jump into an unknown field. Finally, we have large systems which have, as I told you, diverse user community with many users wanting different things, and prioritizing these might be difficult in an ever-changing environment. So requirements evolution is the final step in defining the requirements, and this is a never-ending phase. As the time goes, you see the requirements obviously change. Even the nature of the problem can change. There are, however, some stuff that you can do. So basically, even if you guess the requirements and leave it at a later stage, this might help you to prioritize the requirements. Requirement management is the process of managing changing requirements during the requirements engineering process and also in system development. New requirements emerge as a system is being developed and after it has gone into use. You need to keep track of individual requirements and maintain links between dependent requirements so that you can assess the impact of requirements change. You need to establish a formal process for making change proposals and linking these to system requirements. So like I said, different companies use different strategies to do this. It also depends on what kind of process model you use. In large systems, this is regarded as something you need to carefully plan which ones you have to deliver early and which ones you can deliver at a later stage. Where in agile development, it is basically a lock that they deal one at a time and try to reduce WIP. So by this topic, we actually finished this chapter. So requirements for a software system, we saw the requirements in this specific chapter. We saw the user, system, domain requirements. We can also divide them into functional and non-functional requirements. The functional are the ones that the system must provide, or are descriptions of how some computation must be carried out. Where non-functional ones are related to the good attributes of software. They are fundamental for a software to exist. They can also constrain the system being developed, and without them, the software wouldn't be either secure, effective, performance-wise reduced, and so forth. So every single user requirements needs to be broken down to system requirements. Every single non-functional requirement should also be divided into functional requirements. Finally, we talked today about engineering process, which included 4 different steps: elicitation, analysis, specification, and validation. Elicitation often combined with system analysis. These are spiral activities to identify the business, user, and system requirements. And elicitation often works with the analysis, something I already mentioned. Once you have done this, once you define the business requirements and do the feasibility study to define the user requirements, it goes into the system requirements, and then you can generate a model to validate the requirements. So that is the structure. So basically everything that I discussed in requirements engineering process is actually shown in this diagram, the spiral diagram. If you know that diagram, you know basically requirements engineering process. This diagram basically tells you exactly what's going on. You can also find this diagram on your book, should you want to, and please read the relevant chapter. And I think that's it. That's it for this chapter. Now I am under 7 minutes. What I'm going to do today is that I'm going to give you an exercise, and every time when we join these sections, I am the one talking and you're just there sitting and listening. So we're going to change some roles today. We're going to do an activity together. So I prepared some questions for you. Do you have any questions before we go into the second half of the course? Very good. So I'm going to stop this session here. Please go back to the big blue button and I'm going to tell you what to do. Okay? I'll see you guys in big blue button now, ending this session.